Wall Street firms now use AI to spot market trends and guide investment decisions. These systems analyze news headlines, social media sentiment, economic indicators, and countless other data points to suggest which stocks might rise or fall. But here's the catch. Financial markets are influenced by human emotions, unexpected world events, and countless other factors. Even the most sophisticated AI can't account for everything. During the 2020 market crash caused by COVID-19, most AI prediction systems failed spectacularly. They had never seen a global pandemic in their training data, so they couldn't anticipate the market reaction. This reveals something crucial. AI predictions work best when tomorrow looks somewhat like yesterday. When the world changes in fundamental ways, these systems often stumble. What about predictions that touch your daily life? AI is getting better at forecasting things like traffic patterns to suggest faster routes, product recommendations based on your past choices, maintenance needs for your car or home appliances, energy usage in your house. These predictions work because they deal with relatively stable systems and plenty of relevant historical data. Your driving habits, shopping preferences, and household energy usage follow patterns that AI can detect. Google Maps can predict your commute time with impressive accuracy because it has data from millions of previous trips along those roads. The system knows how traffic typically flows at 5:30 p.m. on Tuesdays, so it can make good estimates about your trip. Can AI help us solve the hardest problems in physics or space exploration? Yes and no. AI is already making contributions to space missions. NASA uses machine learning to identify interesting features on Mars images and predict potential equipment failures on spacecraft. In physics, AI recently helped scientists at DeepMind develop a new approach to a 50-year-old math problem related to fluid dynamics. The AI didn't solve the problem directly. It suggested an approach that human mathematicians then developed into a breakthrough. This points to how AI actually advances science, not as a replacement for human creativity, but as a partner that can spot patterns we might miss and test possibilities faster than we ever could. In medicine, AI shows remarkable promise. Systems can now detect certain cancers in medical images earlier than human doctors, predict patient complications before symptoms appear, identify potential new drug compounds from millions of possibilities. A team at Mount Sinai Hospital developed an AI that could predict kidney injury in patients up to 48 hours before it would be diagnosed by traditional methods. Those extra hours can mean the difference between effective treatment and serious complications. But medical AI faces unique challenges. Bodies are complex and diseases manifest differently across populations. The most successful applications combine AI analysis with human medical expertise. Mathematics might seem like the perfect domain for AI prediction. It's logical, rule-based, and precise. Yet even here, the story is complicated. In 2020, the AI system GPT-3 was tested on university-level mathematics problems. It performed poorly, solving only about 14% correctly. More recent systems show improvement but still struggle with complex mathematical reasoning. What AI does excel at is checking enormous numbers of possibilities. This brute force approach led to AI discovering new mathematical theorems about knot theory and graph properties. The lesson: AI isn't replacing mathematical intuition. It's providing new tools that mathematicians can use to explore uncharted territory. To understand what AI can't predict, we need to recognize some fundamental limitations. The black swan problem, rare, unprecedented events like global pandemics, have outsized impacts but are nearly impossible to predict from historical data. The human factor, people change their behavior based on predictions, creating feedback loops that alter the very future being predicted. Complexity barriers. Some systems are fundamentally chaotic. Tiny changes in starting conditions lead to wildly different outcomes. Data blindness. AI can only learn from the data it's given. Biased or incomplete data leads to biased or incomplete predictions. The honest answer is that AI will get increasingly better at predicting specific outcomes in well-understood systems with abundant data. But general prediction of complex events like the next major technological breakthrough or social movement remains beyond reach. What we're developing isn't a system that sees the future. We're creating tools that help us explore possible futures and understand the patterns that shape them. The most exciting potential isn't AI predicting our future for us, it's AI helping us create better futures together. When doctors use AI to spot disease earlier, engineers use it to design more efficient renewable energy systems, and scientists use it to explore new materials. We're not just predicting the future, we're building it one insight at a time. The question isn't whether AI will let us see the future like fortune tellers. The question is how we'll use these powerful pattern recognition tools to shape the future we want to live in. As Arthur C. Clarke once said, any sufficiently advanced technology is indistinguishable from magic. AI prediction might sometimes seem magical, but it's actually something better. It's human ingenuity amplified by machines that can see patterns we might miss on our own. And that partnership between human creativity and machine analysis might be our best path toward navigating the challenges and opportunities that tomorrow will bring.